So are you guys real SportWit MCAT students?
Hell yeah!
Okay. Let's do one more thing. So I guess this is number 3. Let's talk about combinations, and then we'll start to do problems. It's good to do more and more problems with this stuff. Okay. So combinations are just like before. There is no replacement. Oops, no replacement. But then number 2, well, what's the difference? Before order matters, so now, yeah, order doesn't matter. Okay. So what's an easy example of this? You got 10 people, just like we did before. I want you to pick a group of 3. Can I just nickname that a 3 group? I don't care what order you pick the people in. Whatever order you pick them in makes no difference. All that matters is the people in the group. So what I want to try to do is figure out how many ways can this be done. Okay? So attempt number 1, go with what you know. You know that if you could label the positions, this we know how to do. Isn't that just 10 times 9 times 8? Everybody agree? You also know that formulaically, that's 10 factorial over 10 minus 3 factorial. Right? This is the same as this. We just did that. I want to do this because here's the thinking and then here's the formula. What's the problem? Well, if you had chosen the group ABC according to this logic, right, that's different from that as an answer, which is different from that as an answer. Does everybody agree? Okay, just to make a point, let's write out all the possibilities. Well, that just by freak chance happened to line up really nicely. Because what we did was write this here and we kept A the same and we flipped the other positions, same for B, same for C. But I get it, there's 6 possibilities. Okay, what about this? What if I need your help. I need something about people that is non-offensive. Pierce, that's a great one. Okay, so let's do that. So let's say that everybody has both their ears pierced, okay, or like 2 piercings, okay? And I wanted to count the number of people, but instead I counted the number of piercings. What would happen? I would get, yeah, if I had like, for example, I counted 100 piercings, that's not really 100 people, right? Because each person has 2 piercings. So the number of people would be what? 50. Because for every person I overcount twice, so you need to divide by 2. Does everybody agree? Similar idea. When we do this, don't you agree that all of these were different the way we counted? But if you're talking about a group, aren't these all the same groups? So every single time you pick a group of 3 people, right, you're overcounting how many times? 6 times. So to fix it, what would you do? You would take this number and divide by 6. Everybody see that? Because all 6 of these should only count once. And for A, B, and C, I have all this, right? But degree for A, C, and Z, for example, I would have just as many. So every single time I pick a group of 3, I'm overcounting by 6. So if I divide by 6, we can fix the count. This is the correct answer. If you don't believe that, let's do it with a smaller example so we can actually physically see what's going on. How about, let's pick 3 people. Is 3 an okay number? Or do you think 4? Make it slightly bigger, it's up to you. Okay, so if I have 4 people and I like to pick 2 of them, what do you know how to do so far? You know how to do this. 4 times 3. Does everybody see that? Okay. But that's not the right answer. Right? Sorry, pick 2. That's not the right answer because we've overcounted. Yeah. So if we divide by 2, hopefully we get the right thing. Okay? But let's test that. So here are my 4 people. A, B, C, D. And here are my possible groups. Does everybody agree A, B is a possible group? But you could have picked, the way we counted 4 times 3, that was choose the first one, choose the second one, order matters. That's doing our permutation stuff that I erased, sorry. But that would be like this. Let's see, we should be able to get 4 times 3 is 12, right? If we do this right, we should be able to get 12. So AC, CA. How about BC, CB? How about DA, AD? Okay. Help me, we're missing somebody, right? Do we do CD? BD. BC. BD, BD. DB. I think that's it. Okay, so Do you agree that these are all the possible combinations? And you had 4 choices for the first guy, 3 choices for the second, so it's definitely 12. And that fits our setup that looks like the top part, right? But you've already counted, because every single time, instead of AB is equivalent to what? BA. So if you divide by 2, don't you get 1, 2, 3, 4, 5, 6 options? Which is correct. Everybody see that? That's the same sort of thinking that happens here, just the numbers are bigger. So what I want now is a general principle. The general principle is this. This is 10 times 9 times 8. How did I know to divide by 6? Well, here it was easy. You knew you could screw up because it's either AB or BA, right? 2 ways to move them around. But here, we had 3 guys that can move around, right? Don't actually write this out. We can count this. How many different ways can you range 3 people? 3 factorial. So do you agree that that's the number of ways we would overcount? But 3 factorial is what? Is 6. Okay? So this is equal. Okay, I'm going to erase this because that might confuse people. But is everybody okay with that? What's the formula here? It's all the people. Yeah. Throw away the garbage, right? But then how many good spots did you pick? You picked k good spots, right? But k good spots means you can rearrange them what? K factorial ways. That is it. Using this formula is much faster than it looks. Much, much faster. Why is it much faster? So let's just do this. By the way, what's the symbol for this? The shorthand symbol is n choose k. You should know that symbol. Okay. Can you do n choose k for 10 choose, what did we say, 3? Look how fast it's going to be. You don't really have to think about this in application or in practice, right? Because you know it's going to be what? 10 factorial, right? Don't even think, copy down the 3. That's going to be 3 factorial. And then it's always the difference, 7 factorial. Okay? This will be super fast because you agree this is 10 on down, but this is what? 7 on down. So that only leaves 10 times 9 times 8. And then don't forget this is 3 on down, right? And then that's pretty fast. I'm going to divide by 3. I'm going to divide by 2. And that's 12 times 10. That is 120. Okay? Again, sometimes I care more about the idea of the process than the actual number. And I'm using kind of big numbers here because I don't want to be bound by that. But you know, if they gave you a number like 5 choose 3, you'd be able to do that. Okay? Everybody okay with this? Okay. So useful fact number 1 about combinations. How do you think n choose k relates to n choose n minus k? Meaning, for example, 10 to the choose 7, how does that relate to 10 choose 3? The same. Can you tell me how you know they're the same? Okay, aside from that.
I don't know, so if you subtract 10 minus 7, you're going to get the n minus k value, and then you're going to have to...
Good. So one is arithmetically. This is 10 factorial, just our procedure. 7 factorial, the difference is 3, right? And this is 10 factorial over 3 factorial, 7 factorial, right?
Exactly.
Okay, but maybe a better way to do this, a way to get comfortable with this sort of thing, is what are you doing here? When you're doing this, you have a group of 10 people. How many are you going to pick out? 7. But if you have 10 people, every time you pick out 7, what are you leaving behind? So these numbers must be the same. Because every time you do this action, you're doing that action. Okay, okay, let's go back to using the combination. So are you comfortable applying this with combinations? Okay, if you're comfortable translating from here to here, is everybody okay doing that? Then we don't need to actually write out the final solutions. Problems, you can just tell me how to set them up. Okay? Okay, so let's say you have 2 groups. You have the happy group, and you have the sad group. Okay? And for the happy group, we need 5 people. The reason why I don't want us to solve it out is I'm going to put them in bigger numbers than you might see. And the sad group, you need 5 people. And then how many people are you going to choose from? You're going to choose from 10 people. Okay? My question for you is, I want you to assign people and get me the happy group and the frowny group, right? How many ways can you do this? How many ways can you make the assignments of these people to these groups? I mean, I already did the simplest problem, right? Which is if you have 10 people and you want to pick 3 out, what's the answer? 10 choose 3. Okay, what about this? How many options do you have for the happy group? You can use choosing notation. Does that make sense? Choosing notation. You can use standard notation. 10 choose 5. Do you agree there are 10 people out there? How many you want to pick out without order mattering for your happy group? 5. Does everybody agree? Doesn't matter what order you pick the people as long as you have those 5 people there, right? But you're not done. You have to pick this. How many people are left over once you pick out those 5? 5. And how many are you picking out for this group? 5. And technically, you're not done till you what? Do both actions, right? So this is multiplication. So this is the correct answer. Stressful or no?
So wouldn't that just be 10 choose 5 times 1?
Absolutely.